Hello, welcome to Lunchtime Babbling. My name is Shay Brown. I'm the CEO of Babble AI, a company that audits algorithms for bias, ethical risk, and effective governance. I am joined by a special guest from the company Dots and Lines, .ai, Leon. Thank you so much for joining us. And a little context, um, our two companies sort of found each other in, I'm not even sure exactly where, but we had a couple of conversations, and I think there was such maybe the geeks in us were so aligned, but we got so interested in what the other company was doing that we had to have a podcast because the conversations were so fun. So I'd love you to introduce yourself, introduce Dots and Lines, and then we can chat.
Thank you. So my name is Leon Ingelse. I am the writer and researcher at Dots and Lines. And we met each other through Mert, who's working for Babel, who's also very interested in ethics and responsible AI. My background is mathematics and after that data science, but my passion is much more responsible AI and ethics around AI and optimization. And my company, Dots and Lines, is an optimization company based in Croatia, and we focus on scheduling and routing projects. And yeah, that's a quick introduction.
Yeah, so I think a lot of people would think of scheduling and routing as being like pretty not the most exciting kind of work, right? Um, but as soon as I heard the work that you do and around optimization, like part of what I want to get out of this conversation is to get other people kind of excited about how important this work is. So when you're talking about optimization or scheduling, so let's take one or the other or maybe both. Could you break down a little bit about what does that actually mean in general?
Yeah, so I think when we think about scheduling, we think about possibly the schedules we had in high school, and that does sound slightly boring. But I think that once you're looking at what comes into scheduling itself, there's lots of parameters, lots of different rules that we have to consider. So how to get all these classes full, so looking at schools full of children with the right teachers with the in the right location, that there's not any overlap, and to think about all the other possible rules we can include there. So in the end, it's a very complex problem, scheduling, but routing as well. And what we are also very interested in is thinking about how can we include other rules in it. So, for example, what if we have a teacher that wants to pick up their children from school on Wednesdays? How can we make sure that these preferences can be adhered to? And what if there's teachers that want to have 20 minutes before their classes always to prepare, to be well rested? In this way also actually improving the education that they can give. So all of these little questions are part of these problems. And that is exactly what for us also makes it very exciting.
Okay, so if I think about, so it's like there are constraints that you want to have, um, in addition to just trying to make a schedule or to route some resources or something. Do all of the, is it true? So when you come up with some sort of solution for that, right? Because what you do is that you're coming up with some solution for those problems where you have these constraints. Are all of, do you ever run into situations where the constraints are can't be satisfied, or situations where some constraints can be satisfied and others can't? And like what's the how are the trade-offs, and are all constraints the same or of the same importance? Like how does that stuff kind of play into it?
Yeah, so the constraints is the more technical term, and we also use rules. But if we look at, so we've got different types of constraints, right? We've got very fixed constraints, we call them hard constraints, and we've got less fixed constraints, soft constraints. Hard constraints can be, for example, two classes cannot be at the same time in the same room. You cannot give Spanish and German together. That would be very interesting. But the looking at from that perspective, that is just something that would make the schedule infeasible. Other schedules, hard constraints could be that a teacher is just not available on Fridays, that a classroom is not available at a certain moment, or for drivers for routing that a car goes through a one-way street where it's not supposed to go through a truck, for example. Um, on the other hand, there's also soft constraints. These are, let's say, less strict and rather constraints that we would like to adhere to. These can be decided also by the actual use case. But examples for these are, for example, teachers that want to have a certain preference, but also truck drivers that would like not to work at certain types. And then we also have other constraints like the law. A truck driver has to rest after driving for 2-3 hours, depending on where you are. And all of these different constraints, they can actually also be competing with each other. And then you're also getting into a space that can create questionable outcomes. So what do we want? Do we want to adhere to the law? Rather, yes. Do we want to adhere to the sleep deprivation of a truck driver? Do we want to actually make sure that the client is happy? All of these questions start to come into play, and where do we position ourselves to look for a best solution?
That's yeah. I mean, it's so fascinating because the overlap with the kind of work that Babel does, it's pretty significant in the sense that like most of the time we're dealing with an AI system that has constraints like compliance, and there are trade-offs between different things that you can prioritize. But the thing that I like so much about what you do is that it's so formalized. It's like you really have to you have to encode it mathematically, and I think there was in our community a little bit of history. There's this sort of fairness, accountability, and transparency community, which is still around. Of course, a lot of academics and people publishing work on fairness metrics and incompatibility theorems between different kind of metrics for fairness, and it was there was a lot of quantification of it, and then there was kind of a movement to pushing back against that quantification in the sense of you know not reducing everything that was ethical or
Huh.
down into numbers. But I think that there are some cases, in the case of like safety or compliance, where you kind of have to comply with the law, where it is important to get down to the numbers and to get down to something that's really easily measured. And how, yeah, what are your thoughts on your experience thinking about those things where that there's going to be trade-offs? Like, how is the process for you guys when you're working with a client to step through that and really make those tough decisions?
Yeah, so I think it is true what you said at the beginning is that we're formalizing a problem. I think this is a very big part of our work, is to actually first have a look at what is the actual problem. So a big part, especially at the initial phases, is understanding the problem, understanding the different constraints, understanding the needs of different stakeholders, and then making, they call it a digital twin. So making a digitalized version of the problem itself. And from that point on, tweaking where do we want to go? What constraints do we want to give more importance? And then as a second part, I think you're saying how, like, quantifying ethics. That is a very interesting ethical question now on itself, and quantifying fairness. Mostly what we do is looking at what do stakeholders find most important. We always are working with the client, so we also have to look at the business needs. But oftentimes, business needs also work very well in parallel with, for example, employee needs, um, their clients' needs, and all of these things together. What is very interesting is when do these things compete, and how do you deal with that? For example, one client was for who we work. We schedule their employees, And sometimes one employee has a very nice schedule and another one does not. How do you deal with that? And how do you actually define what is a good schedule? And how do you how do you grant certain employees their preferences and others not? When do you decide for one preference to be more important than another one? What if one parent of one teacher wants to stay not to work on Wednesday afternoon because they want to spend time with their kids, and another wants to play football? How do you decide on that? What is the trade-off there, and who do you decide as a company actually grant their preference? I think that it is we have certain methods for this. I think one interesting thing about all of this is that by formalizing, you're actually asking people to make a decision before we come, for example, into play. Before we are formalizing these problems, there are already the same decisions made, but they are not formalized. And actually, by making this digital twin, by discussing the problem, you are actually asking questions that for many people are already answered inside of their head, but by actually asking them, they will be answered in a more formalized way. And I think one last thing I would like to say is that for one project, we're also looking at looking at a karma system, we call it. And here we are thinking of, well, what if we grant a preference to this employee one day and then to the other day? So to look at how happy are they, and this is again something that's very hard to measure, but how happy are they with schedule, and can we then look at the future and grant preferences in another way so that this happiness in some way is balanced throughout a longer period. So this difference between short-term fairness and long-term fairness, or good schedules. I hope that answered your question.
Yeah, no, that's super fascinating. And so for the majority of the problems, it sounds like there's like a instantaneous sense of like, this is a good schedule or this is good routing based on these constraints or rules. But then now you're talking about temporally, it's like integrated over time. There might be some considerations that might persist through time where I'm looking at the past. This employee was disadvantaged.
Exactly.
And therefore, I want to credit them in the future. And is that something where, I mean, obviously optimization problems like mathematically could work over time scales as well, but how often is that considered normally? Is it normally fairly snapshot in time? Like, is this a new domain for you and for people to think this along the sort of like time horizon?
Yeah. So I think the question, what is a good schedule and in which way do you advantage a certain employee? The question, what is a good schedule, is a question that is asked every time we start a project as such, although we don't really realize it. And deciding on what is a good question and looking at it in a more temporal way. So looking at it can be disadvantaged on the long term, on the short term, but then this is credited back through such a karma system. We have not seen it before, but yeah, you can deal with that in different ways. I think also what is important is that different clients have different needs. So a school would like to actually oftentimes wants to have a timetable for the rest of the year, or maybe for the semester, let's say. But for very high volatile environments, people might want to reschedule every week, or want to also deal with very quick changes. For example, when you need a substitute for someone to be being ill. So it also depends on that.
So, all right, there's quite a few questions I want to get to, but let me get to one of transparency.
Mm-hmm.
So, a lot of regulations around algorithmic systems that kind of make some decisions, and where like scheduling an employee would be a decision. A lot of them are pointing towards the ability to get some sort of explanation for like, why was I scheduled in this way, or and so how does that look? What does that look like in this type of algorithm?
Yeah.
Because I know that in a lot of other ones, those explanations are oftentimes very difficult to come by. How is it here with these types of optimization algorithms?
Yeah. So I think that this already comes to a very fundamental question about the algorithms, the models that we use. When people think about AI, they often think right now about LLMs, about ChatGPT, Claude, all of these, or maybe recommender systems, neural networks. And the work we do, our optimization algorithms, are very different from them. So they are normally data driven. So you throw a lot of data to a problem and you extract patterns and extrapolate that. But our algorithms work, as I said before, by problem definition. The transparency issue is very different because of that as well. Normally, for example, with LLMs, all of the data, there's so much data thrown at these algorithms, at the training of these algorithms, that it's impossible to actually understand what they have extracted from it, what patterns they've extracted. From us, the problem definition is very transparent. However, oftentimes the solution space, we call it, so the number of solutions possible based on that problem is huge. And searching for the solution can bring you into different results. And the way the algorithm works is that in the end, finding the best, the optimal solution is very hard. And also the problem actually, because the solution space is so huge, it's really hard to actually find the most, the optimal solution. And normally you find some very good solution, so suboptimal solution. However, why we reach a certain solution is very hard to see and can actually be influenced by certain technical decisions that we make. So when you're asking me, what if someone questions us, why did I receive this schedule? Why am I working on that and that date? On the one hand, we can say very little. It can be hard to actually say something about the reason why we find a result. But on the other hand, we can say things about certain constraints having to be met. So if a person asks that and asks why is that person working, we can actually explain oftentimes based on the constraints that we had to adhere to, why a certain solution was derived.
That makes sense. So I'm trying to to draw a parallel with like a deep neural network. And I think that most of the time for those systems, you're not going to be able to get a global answer to an explanation, in the sense that, these things were considered globally, this is what it's doing. But locally, you can get some local explanation, like this was the most important thing, or that was the most important thing. And for you, it sounds like you have a globally much better, maybe not globally in the sense that like this is the best solution globally, but globally, here are the constraints. Like people just can't work in the same classroom, or you're not allowed to work without this much sleep. And so you have good global explanations. And then locally, you would have, I guess you'd be better off there too, or at least as good off as the other algorithms, because even locally you could say, well, I know that if I shifted you 1 hour to the left, it violates this constraint. If I shifted you 1 hour to the right, it's going to violate that constraint. And so this was the best option locally too. And you can do it with other parameters. Is that the right kind of reading of that?
Yes, I would have to think about it a little bit more, but it does sound very, especially like what you're talking about, the way the algorithm works. So from a more algorithmic or design perspective, it's much more clear. And I do think that there are still questions to be had at the end, but it's much better than a deep learning model, a deep neural network. And I think what is also super important to understand is that last solution, so the actual schedule that we provide, is checkable and understandable very often. I mean, a schedule can be huge, so it can be hard to oversee, but it is understandable to the human eye. So the actual result makes sense. And from that result, you can also extract uh, more knowledge. Whereas, yeah, I think that's important. And because of that, there's also always a human in the loop. So we are not scheduling, we're not fixing scheduling. Like there will always need to be someone to actually put the schedule out there. But we also call it normally AI assisted scheduling. So where normally a scheduler is working hours to actually put out a first schedule, this whole process we help with. But the final result will always have a human in the loop to check whether everything makes sense. And it's easy to check as well. So yeah.
So do you envision a a scenario where this may not be necessary, or where you're gonna have a client who's gonna say, we want to schedule these things automatically, and we don't want a human in the loop? So this happens with things like delivery drivers for fast food, or like Uber style, those things of humans not checking whether which car is getting pulled up. It's some algorithmic system. And do you feel like the these sorts of models are going to be well suited for that, or do you think like there are some inherent limitations? What are your thoughts there?
I would say that yes, it's possible. You can do it without any human in the loop, and you can push the push it out without checking it. I think it will be actually much better than data-driven AI models still, and much more reliable, because you can actually code in very strict rules, very strict. So the hard constraints can be very strict, and if it doesn't work, then it doesn't work. The problem is that often the problems that we're trying to deal with, the problems that we're dealing with, are extremely complex. So having a human in the loop can actually improve the algorithm by a lot. And also from our client base, from our perspective, we normally work with very custom-made products. So the software we make is very client-specific, and they want us because we are working with kind of very high risk problems. So problems where there's a lot of compliance necessities and such.
Like safety critical things.
Exactly. So for them, it's always very important to actually have a human in the loop. But in the end, I like, if you want to do that, yes, you can do that. But as I would say, similarly for most of the AI, data-driven AI products, I would say that a human in the loop is almost always very important. Yeah, and I think it's also different because the many LLMs, they are working also based on putting out a lot of output. And if you want to check everything, it does take a lot of time, and it would be very it would be very costly. Whereas here, the actual schedule is oftentimes thrown out there once a week, like at the tops. So it only is necessary when it becomes complex.
I see. And so the yeah, I mean, I was going to ask about because I know there's a lot of people with LLMs now who are now thinking to themselves, well, I could just have a large language model. I'll just say I need a schedule for the school, and I want to optimize for this thing. I want to optimize for that thing, and they'll essentially prompt it to do it. And what would be your response to people who just say, I'll get Claude 4 now, or O3 from ChatGPT to manage my schedule for me? Where would they be wrong there?
So I think that the work we do requires very like, you have to understand the context a lot. You have to understand different business needs. You have to actually be able to weigh them in and push out something that adheres to everything. I think that right now there's a lot of buzz around LLMs. Everything that I've seen so far shows that they are not able to understand context. And besides that, I think that finding a solution to the problems that we deal with is always such a complex endeavor, because there's such a huge solution space. So finding something within that solution space is super hard. And this is very different from, for example, someone having their own schedule, which is one person needing their own schedule, in comparison to scheduling 100 different people or 1,000 different people and having all of these different constraints dealing with. And Claude or ChatGPT is just not able to do that at all.
Yeah. Yeah. I mean, I think I would say, like, most of the time, if let's say they did an okay job with one instance of a schedule, the thing that you would not know, the thing that would have to be doing is implicitly doing some of the same kind of some of the same logic that's happening, right?
Yes.
But you don't know to the extent to which it's done it. And then whatever you get out at the other end doesn't have any of the visibility into the success of that. Like, it would just be a schedule. It wouldn't have any sense of, like, is it really good relative to those constraints, or not so good relative to those constraints. And it feels like with formal optimization like this, you know that, you can see the difference between one schedule and another schedule.
Exactly. And I think this is also very beautiful about this formalization process, is that you are creating that whole logic. This is a very good point as well. Yeah, definitely.
So one thing that caught my eye here, which feels like a really difficult part of the whole problem, is that digital twin aspect.
Mm-hmm.
Because businesses can be really complicated, and different processes can be very, very complicated. And so it seems like a non-trivial aspect to come up with the formalization of that. I'm assuming by digital twin, it's not necessarily like I can see the schedule in front of me, but like it's more like the mathematical formalization of what does that schedule mean in terms of numbers and parameterized in a particular way. That seems like a hard job. And so how hard is it? And are there things that are easier or harder to create a digital twin for?
Yeah. So I think, for like to first imagine a digital twin, we like to talk about railways, and then like this little railway model that you used to play with as a child, with which you could then play around with, so that you so that would be the digital twin, on which you then optimize before you actually throw it into in the real world. But this part of building a digital twin is huge. It's very important, and it's actually one of our biggest expertises, is having this knowledge extraction process from our clients. So we need to understand what is happening, what is their problem, what are their needs. And to do this, we need many talks. We need to actually understand what will the impact be of a certain decision that is made, because you can define a problem in different ways, you can define constraints in different ways. And what is most interesting is that people think, especially because of the shiny products that are right now out there of AI, that it's a very easy process. But to actually define the whole process and make a digital twin, it takes a lot of time, and it takes a lot of discussion. It takes a lot of stakeholder involvement, and it is necessary to actually structure and formalize all of these processes to start building the digital twin. So when you ask me, is it a hard process? It's super hard, and it requires both our expertise of the technicalities of the problem and we need the expertise of all the people involved. So that means both the business people, but also the people that are going to use it, the people that are going to be affected by it. Yeah, all of that, all of them.
And so,
And the law, by the way, also like, so also keeping that in mind.
oh yeah, the law, of course, like, and the different laws, right? Like you deal with, you must have to deal with labor laws in different jurisdictions and things like this. Is that how difficult is that to track?
Exactly. I think that's one of the things. And not only it's hard, it's also that we come with our experience from different projects. And every time we start a new project, we have to leave all the assumptions behind because scheduling a truck driver is very different from scheduling a teacher. And indeed, dealing with different jurisdictions. We live in the EU where we, in a certain way, we've got a uniform law, but we also have then local law in all the different countries. I think it's the same in the US with the states on a state level. I don't know how different that is, but to deal with all of that and every time consider that again, it's very complex.
Yeah, that it does sound complex. I think it feels like the digital twin aspect is one area where data could actually ease that process. You know, things like, I'm assuming simple things like how long does it take a truck driver to go from sleeping to driving, and you must have to abstract that to some estimation, but getting data on that kind of thing ahead of time, I'd imagine that over time, as we get better in businesses that collecting data, that could feed into making the abstraction easier or at least more accurate. Does that sound right?
Yeah, I think it's like for the formalizing of certain constraints, it can definitely help to inform yourself through data. And the example that you take is it's a very good example because there's actually, for example, the law itself is oftentimes already formalized. So when the law says we need 30 minutes of break every 2 hours that we're driving, then that is the law and it's very clear and we can adhere to that. But if you talk to truck drivers and they're saying, look, I can take half an hour break or I can sleep for 5 hours, but after that I just need another hour to get up and running, you have to deal with that as well. And therefore, you can indeed deal with data. For example, what we also work with is the distance that certain students have to traverse between classes. This is all very important to also actually schedule them better.
Oh, wow. So you'd have to have some mapping between,
Exactly.
for each pair of classrooms, how much time roughly does it take to go from one classroom to another classroom?
Yeah, for example, or between clients when a truck driver has to, or like a delivery person has to do one thing somewhere, then something else somewhere else. We also, I think there's a very nice example also of plumbers. They also have to know if one plumber has to go from one client to another, you have to know the distance, but you also have to know, you have to estimate how much time they're going to need at every location. All of these kind of things will definitely benefit from more data understanding.
Wow. So I want to talk a little bit about Dots and Lines as a company now, just to kind of finish up. Like, what's happening? Like, what's the vision now? Like, so I'm totally fascinated, and I personally think that the whole field of AI and automation, it's like, from the AI safety aspect, as things get more and more connected, we're going to need many more of this kind of work to overlay on top of more traditional. I don't want to call it traditional. More like stochastic or random kind of machine learning, or kind of opaque. Like, so, but where is Dots and Lines going? Like, in terms of products, are you going to be a totally service industry, like a professional services, or are you branching into products? Like, what's the kind of vision for where you want to see yourself kind of 5 years from now?
Yeah, so I think that is, I'm not completely the best person to say that, but if I, how I envision the field of optimization, but also Dots and Lines' position in that, I think that on the one hand, we are right now seeing a very big AI hype, and there's a lot of controversial things happening. And they are mostly happening with the neural networks, the stochastic models, uh, also because there's a lot of problems there. I think that the optimization models that we use are possibly less famous because there are less risks. So there is less problems, and problems make uh, marketing, although possibly, I don't know, someone said there's no bad marketing, I believe. But so what I imagine optimization to, like the position that it takes is that what we are doing is we are optimizing processes almost everywhere within industries and societies, and we do it well. We are having very good results already for years, but we've not been noticed so much. Um, and I think that uh, I imagine it to get more notice now also by riding that wave of the AI hype. But on the other hand, I think also that what we do really well is that we can actually do it in an ethical way, in a responsible way. And what I hope for Dots and Lines is that we will be able to actually explain that better around the world, and to different parts of society and industries. I don't know if that's answering your question.
Oh, I think yeah, no, I think so. Um, and do you think you'll remain kind of just strictly professional services, or do you think that you're going to think more about there'll be products in the future, let's say,
We are, I
or is it or is it too like you don't want to give anything away, which is okay too.
I don't know. Yeah, I don't like. I think that it is. I think it's a very difficult question. First of all, because I believe personally that there's very few places where an actual product could work, and the because the many of the problems always need a custom-made solution. However, there is also, on the other hand, many areas where can be products possible. And we are also developing things internally and seeing where we could actually bring that out.
Yeah, I mean, I think that's a smart, like just from Babbel's perspective, we're in a similar boat where sure we could build products that might be useful in some cases, but what we found is like some of the hardest problems are need to be solved by people still and services. Like you had to, it's more the framing of the problem is the real issue. It's not so much the widget that comes out at the other end.
Exactly.
So I think that's a smart approach.
I think it's also like as you grow, you start to understand, like you're building on other things always. Like you're not just starting from scratch, and the better you get, the more experience you gather, um, the the more you build on previous work. And on from that perspective, you could say we are already building products with the just by doing. Um, but yeah, and also besides like the most interesting work, I think that I don't know how it's at Babel, but the most interesting work are all of these custom made solutions, like actually going into the problem. So when you've got the same thing happening over and over, it's going to get a little bit boring.
Yeah, absolutely. I mean, this so many parallels I think between the two companies because we feel the same. Like we want to solve the hardest problems in the world,
Yes,
and it's if there was a product for it, then there wouldn't be the hardest problems in the world anymore. And so that's the that's the cutting edge that I think we always want to stay at and let other people build products for it.
yeah, and I think yeah, and I think that it is those questions that excite us the most, is those problems that come together with all of these different players, all of these different so stakeholders, all of these different very fundamental questions to what is the actual fair or good schedule, and then coming together and finding out what that means.
Well, that's amazing. So that's a perfect place to stop this. So thank you so much for coming.
Thank you for having me.
Yeah, and I can't wait to see where to keep in contact, see where the company goes. I think people should reach out to you. We'll put your website below and your blog. But I think that for those like responsible AI people who are listening, which is typically who listens to our podcast, I think this is an exciting area to pay attention to, because we need this kind of work where it's like we have some certainty and some formalization around the things we care about, and we can't offload everything to large language models. There are some things that we have to have some certainty about, especially in safety critical or rights critical areas where people's fundamental rights are impacted. If you're listening to this on a podcast, thank you so much for listening. If you're watching this on YouTube, a like and subscribe would always help. And we'll catch you next time on Lunchtime Babbling.